Hello everybody, welcome to the I Am IT Geek YouTube channel. My name is Shabazz and as ever I am the IT Geek. Welcome back to today's YouTube episode, which is back on that AZ700 designing and implementing Microsoft Azure Network Solutions sort of study topic. Today we're at the end of Module 2 and this is the last episode of Module 2, which is all going to be around monitoring networks. Normally, as you know, Mohammed Sajid, a good friend of mine, you can see his socials in the description. He normally joins me at the end of the episode to do like a demo and like a lab. That's not going to be the case today. We've not got a lab with this, so I'm just going to be talking about monitoring networks. But then for Module 3, Mohammed Sajid will be back with me. So without further ado, let's get started with this episode. So as I mentioned, we're at the end of Module 2, which is designing and implementing core network infrastructure. Today we're talking about monitoring networks. So we're going to cover configuring, monitoring network diagnostics and logs in Azure Network Watcher. We're then going to talk about monitoring and repairing network health by using Azure Network Watcher. And the last two topics are going to be around activating and monitoring DDoS Protection and activating and monitoring Microsoft Defender for DNS. So let's start by talking about configuring, monitoring network diagnostics and logs in Azure Network Watcher. So Azure Network Watcher is a regional service that enables you to monitor and diagnose conditions at a network service level in, to, and from Azure. Scenario level monitoring allows you to diagnose problems and end-to-end network level view. And that network diagnostics and visualization tool that's available with Network Watcher helps you understand, diagnose and gain those insights to your network in Azure to help you sort of solve problems. As I mentioned, you can monitor and diagnose networking issues without logging into your virtual machines with Network Watcher. Trigger packet capture by setting alerts and gain access to real-time performance information at that packet level. When you observe an issue, you can investigate in detail and better diagnose. So, we don't need to log into virtual machines connected to the network to troubleshoot. We can do it all from the portal or through PowerShell. You can build a deeper understanding of your network traffic pattern using network security groups. Using network security group flow logs, the sort of information provided by flow logs helps you to gather data from for compliance, auditing and monitoring your network security profile. Network Watcher provides you with the ability to diagnose the most common sort of VPN gateway and connection issues as well. So allowing you not only to identify the issue, but also use those detailed logs created to help further investigate. So again, a very, very powerful tool. Let's continue with this topic for a second. And when we're talking about network topology, the topology capability enables you to generate a visual diagram of resources in your virtual network, so it lets you visualize it, and those relationships between the resources as well. Another good tool within your Network Watcher, another good feature is verify IP flow. So this is you can quickly diagnose those connectivity issues from or to the internet and from or to your on-premises environment. Example of this is confirming if a security rule is blocking ingress or egress traffic. That's quite a common one. To or from a virtual machine. IP flow verifies it's ideal for making sure your security rules are being correctly applied and working as they should be. When used for troubleshooting, IP flow verify doesn't show a problem, you will need to explore other sort of areas such as firewall restrictions to kind of find that. So we also have a good feature called for Azure Network Watcher called Next Hop. So when you want to determine if traffic is being directed to the intended destination, you can do that by showing the next hop. This will help sort of determine if network routing is correctly configured and working. Next hop also returns the route table associated with the next hop, and if the route is defined as a user defined route, that route is returned. Otherwise, the next hop system route is normally shown. Depending on the situation, the next hop could be the internet, could be virtual appliance, could be virtual network gateway, VNet local, VNet peering, or could even be none. We also have something called effective security rules. So network security groups, or NSGs, are associated at a subnet level or at a NIC level, not the VNet level. When associated at that subnet level, the NSG applies to all the VM instances within that subnet. Effective security rules view returns all the configured NSGs and rules that are associated at a NIC and subnet level for a virtual machine, providing insight into sort of the configuration. Finally, we have that sort of VPN diagnostics, which we mentioned. So you can again troubleshoot, and there's a VPN diagnostics feature within Azure Network Watcher, which lets you help diagnose any issues you might have with your site-to-site VPN or your point-to-site VPN. Final feature I want to mention is the packet capture. So Network Watcher variable packet capture enables you to create packet capture sessions to track traffic to and from a virtual machine. Packet capture helps to diagnose network anomalies both reactively and proactively. Other uses include sort of gathering network statistics, gaining information on network intrusions, and to debug sort of client-server communications. So for those with a networking background, you'll have used Packet Tracer, with your on-premises networks quite a bit. So let's move on to talking about monitoring and repairing network health by using Azure Network Watcher. We've talked a lot about the features. So you need to initially set up Connection Monitor, and there are several key steps you need to perform in order to set up that Connection Monitor for monitoring. So the first thing is you need to install the monitoring agent. So Connection Monitor relies on lightweight executable files to run connectivity checks. It supports connectivity checks from both an Azure environment and on-premises environments. The executable file that you use depends on whether your VM is hosted on Azure or on-premises, so it can differ. Next step is to enable the Network Watcher on your subscription. So all subscriptions that have a virtual network are enabled with Virtual Network Watcher. When you create a virtual network in your subscription, Network Watcher is automatically enabled in your virtual networks region and subscription. This automatic enabling doesn't affect your resources or incur any sort of charge. So you ensure that Network Watcher isn't explicitly disabled on your description. And then once you've done those steps, you need to then create a Connection Monitor. So Connection Monitor monitors communication at regular intervals. It informs you of any changes in reachability or latency. You can also check the current and historical sort of sources, the current network topology between source agents and destination endpoints. Sources can be Azure VMs, or they can be on-premises, as I mentioned before, that have that installed monitoring agent. As we said, the agent differs as well. Destination endpoints can be Microsoft 365 URLs, dynamic 365 URLs, or custom URLs, Azure VM resource IDs, IPv4, IPv6, FQDNs, or any sort of domain name. Once you've created that network monitor, finally then you need to set up data analysis and alerts. The data connection monitor collects the data it collects is stored in the Log Analytics workspace. So you set this workspace when you create the connection monitor, and monitoring data is also available with the Azure Monitor Metrics as well. You can use Log Analytics to keep your monitoring data for as long as you want. Azure Monitor stores metrics for only 30 days by default, so doing it in Log Analytics will give you more time. And once all this is done, really, you're ready to diagnose your issues. So just sticking with this topic for the time being. Again, talking about creating that sort of a connection monitor. In Connection Monitor that you create by using Connection Monitor, you can add both on-premises machines and Azure VM resources, as we mentioned. These connections monitors can also be connectivity endpoints. So just wanted to touch on some of the actual entities that are part of your Connection Monitor. The first one is a Connection Monitor resource. So this is a region-specific Azure resource. All the sort of entities are properties of a Connection Monitor resource. So all these properties that we're going to mention now, the first one being endpoint, so a source or destination that participates in connectivity checks. Examples of that can be Azure VMs, as we mentioned, or on-premises agents, URLs and IPs. Another entity and that you'll see in the configuration is that test configuration. So this is a protocol specific configuration for testing. Based on the protocol you choose, you can define the port, thresholds, test frequency, and other parameters. Another entity that you can configure is the test group. So the group that contains source endpoints, destination endpoints, and test configuration. A connection monitor can contain more than one test group, so make sure you make a note of that. Final entity of creating a connection monitor that I wanted to mention was test. So the combination of source endpoint, destination endpoint, and test configuration. A test is the most granular level at which monitoring data is available. So the monitoring data includes a percentage of checks that failed and the RTT, or round trip time. So about halfway through this section, I just want to start talking about activating and monitoring DDoS protection. So Azure DDoS Protection provides detailed attack insights and visualizations with DDoS attack analytics. Customers protecting their virtual networks against DDoS attacks have detailed visibility into attack traffic and actions taken to mitigate the attack via the attack mitigation reports and mitigation flow logs. Rich telemetry is exposed via Azure Monitor, including detailed metrics during the duration of that DDoS attack. Some key benefits of DDoS protection are that it's one of them is always on traffic monitoring. So your application traffic patterns are monitored 24/7. You're looking for indicators of sort of DDoS attacks. Azure DDoS protection instantly and automatically mitigates the attack once it's detected. Another good benefit is adaptive real-time tuning. So intelligent traffic profiling learns your application's traffic over time, and then it selects and updates a profile that is the most suitable for your service. The profile adjusts the traffic changes over time. Another really interesting benefit is the telemetry monitoring and alerting. So Azure DDoS protection applies 3 sort of auto-tuned mitigation policies, TCP SYN, TCP, and UDP. For each public IP, the protected resource in the visual network that has DDoS enabled. The policy thresholds are auto-configured via machine learning-based network traffic profiling. Finally, DDoS mitigation occurs for an IP address under attack only when the policy threshold is exceeded. Final sort of benefit I wanted to touch on was rapid response. So during an active attack, Azure DDoS protection customers have access to DDoS rapid response, or DRR. So that's the name of the team. And they can help with attack investigations during an attack and post-attack analysis. So again, some really good features. So when we talk about activating the monitoring and DDoS protection, some of the high-level steps are you need to create the DDoS protection plan first of all. Then you need to enable DDoS protection for the VNet, validate that it's kind of working, and then test it's working. You can configure Azure DDoS protection plan using Azure Firewall Manager as well. So let's move on to the final topic now. So coming towards the end of this topic and this module, we'll talk about activating and monitoring Microsoft Defender for DNS. So Microsoft Defender for DNS provides an additional layer of protection for resources that use Azure DNS Azure provided name resolution capability. Microsoft Defender for DNS detects suspicion and anomalous activities. And some of the benefits of it are the sort of data exfiltration from your Azure resources using DNS tunneling. Malware communicating with command and control servers, it kind of detects that. Detects DNS attacks communicating with malicious DNS resolvers. And it also detects communication with domains used for malicious activities such as phishing and sort of crypto mining. So when it comes to activating it, you enable the enhanced security features on the subscription level. So if you go into Microsoft Defender for Cloud, you'll see Microsoft Defender for DNS there as an option as part of the plan to enable. You can also enable other aspects of Microsoft Defender for Cloud as well, like for storage accounts, for example. So that they can be either subscription level or resource level, whereas obviously Microsoft Defender for DNS is subscription level. You've got Microsoft SQL for Defender, either the subscription level or resource level. You've got Microsoft Defender for open source relational DBs as well, at the resource level only. And finally, Microsoft Defender plans available at the workspace level are Defender for servers, Defender for SQL, and for SQL servers on machines rather than SQL for the Azure service. So that brings me to the end of this topic. So again, very much a theoretical episode today. So no lab, so we're getting straight back into the lab in module 3. So you'll have Saj back. So yeah, again, it's been a really, really long module. Feels like a long module too. We've covered a lot of ground. So thank you for sticking with us. I hope this is helping. We do have my socials in the URL, Saj's, and a URL to the labs from GitHub if you are carrying on kind of with the labs. So yeah, thank you for everybody's support. Don't forget to like, comment, subscribe. As of this recording, I'm about 20 subscribers away from 1,000. Who knows, by the time this comes out, I might already be at 1,000. But yeah, thank you for everyone's support. And until next time, goodbye.